So let's see some examples of average rate of change. This first one says the concentration C in milligrams per milliliter of a drug in a patient's bloodstream is monitored over 10-minute intervals for 2 hours, where T is measured in minutes as shown in the table. So T is our input, our X value. In C, the concentration is our output. You give me the minute, I give you the concentration. So we're going to try to find the average rate of change over a given interval. Before we even get into this, I want to make sure you even understand what the average rate of change is. Remember, it's the change in Y over the change in X, or the change in the dependent variable over the change of the independent variable, the change of the output over the change of the input. So we said the input here is time. We said the output here is the concentration. So this is going to be concentration, change in concentration over change in time. Why do I care about this? Because when we're dealing with real-world problems, we always want to label our answer. And these answers, or the labels of the answers, is not easy. So what was the units for concentration? The units for concentration says it is milligrams per milliliter. So this is milligrams per milliliter. All right. And what was our change in time? Time is measured in minutes. So when we find a rate of change, whether it be an instantaneous rate of change or in this case an average rate of change, when we find that rate of change, the units are milligrams per milliliter per minute. I know that's a mouthful, I know that's crazy, but I wanted to get that out of the way so before you see the numbers, you don't get messed up just off the units themselves. Okay, now's the easy part. It says find the average rate of change over the given interval. So let's use some colors here. We're going to start with 0. Oops, sorry. Let me use the highlighter. We're going to start with 0. And we're going to go to 120. So here's 0, and here's 120. We need to be really, really careful here. Remember that it's the change in C over the change in T. So the change in C over the change in T. So in this case, the change in C, the C value was 68 for the second point, 0 for the first point. The change in T was 120 for the second point, and 0 for the first point. Go ahead and put this into your calculator and let's see what we get. As a decimal, let's see if it says what to do here. I don't see that it says round to the nearest decimal or fraction or anything like that. Let's go ahead and do decimals to, I don't know, how about 3 decimal places. So go ahead and throw 68 minus 0, which is 68, over 120 minus 0, which is 120 into your calculator. And let's see what it is. I'm getting 0, please double check my math, 0.567. Okay, so let's figure out our units here. This is ridiculous, but this is what it is. 0.567, that's positive, so that represents an increase. And that's milligrams per milliliter per minute. So from 0 minutes to 120 minutes, it increased by the amount of concentration in the blood system, increased by an average of 0.56 milligrams per milliliter. So every single minute, that concentration increased by that amount. Let's look at the average rate of change between 90 minutes and 100 minutes. So I'll use a different color on this one. How about blue? Let's find when it's 90 and 100 would be right there. So again, when we're doing this, we want to do the change in C over the change in T, output over input. So that'd be 113 minus 113 all over 100 minus 90. That's the change in C over the change in T. Well, that's 0 over 10, which is 0. So what does that mean? What does that mean? So that's 0 milligrams per milliliter per minute. That represents, on average, over those 10-minute time period, from 90 minutes to 100 minutes, there was no change Again, we're not saying what the actual concentration was. We're just saying there was no change in the concentration. So the 0 doesn't mean there was none in the bloodstream. In fact, there was 113 milligrams per milliliter in the bloodstream. All we are talking about is how much did it change over that time. Okay, let's look at the last one here. I'll go for green on this one. Here's 90, green at 90, and then green at 120. We've seen all these numbers before. Again, let's remember that we're trying to do the slope, the average rate of change. So we're going to do the change in concentration over the change in time. So the first concentration was 68. Sorry, the second concentration was 68. The first concentration was 113. The second time was 120. And the first time was 90. Go ahead and throw that into your calculator and see what you get. Please verify with me. I'm getting negative 1.5. So what does that mean the answer is? That would be negative 1.5 milligrams per milliliter per minute. So interpret that. Think about what that means. You have a concentration measured in milligrams per milliliter. It means from 100 minutes to 120 minutes, from that time period, from 90 minutes to 120 minutes. During that time period, the concentration went down on average by 1.5 milligrams per milliliter each one of those 30 minutes. Now that doesn't mean that that's what it did. It didn't go down each minute. It didn't go down that much. It just means on average over that entire time period. That's what it went down by. Okay. What's another thing? So that was like the secant line, change in y over change in x. What's another one we can use it for? How about average velocity? Average velocity, again, change in distance over change in time. Average velocity, if you know velocity, the formula for velocity. The one that I know is, I call it as DIRT, distance equals rate times time. So this one solved for the rate. So to solve for the rate, you would divide both sides by t. And you would have the rate, or the velocity, is the distance divided by the time. So if we wanted to know the change in the velocity, the change in the rate, we would look at the change in the distance over the change in time. So let's look at the next one. It says the height s. Why do they use the letter s and not h? I don't know, but we'll go with it. It's always s. Of a free-falling object at time t in seconds is given by s of t equals negative 16 t squared plus 180. Find the average velocity of the object over the interval. So let's think about this again. We're going to the change in velocity is the change in distance over the change in time. Let's go over our units real quick to make sure we understand this. So we're starting off with change in distance, which is height here, and this is measured in feet. And on bottom, we have the change in t time, which is in seconds. So each one of these answers labeled is going to be feet per second. Feet per second is our velocity. So let's look at this. What is our average velocity from 0 seconds to 1 second? Again, to find that average velocity, we're finding the slope. This is going to be the change in distance over the change in time. Change in time. So in this case, well, we know what our time is. They're giving us a time of 1 and they're giving us a time of 0. But we need to find our distance. So how do we find our distance or our position, or in this case, our height? So how do we do that? Well, we actually need to do some math. We need to find out what's the height at 1 second and what's the height at 0 seconds. So how do we do that? Well, we can simply use our table feature. We're going to be plugging in a bunch of these values for us. So here I'm just going to put in, I'm going to do a table just like we did in the limits section and in the review sections. I want you to get used to doing tables here. So we're plugging everything into the position function, which is negative 16t squared plus 180. The values that we need to plug in are every value that you see here, a 0, a 1, a 2, and a 3. So that's what I see for all of the problems. So again, what I'm doing now is on my calculator, I'm hitting table. I'm clearing out anything that's there. I'm going to type in negative 16 t squared, which is really an x, but that's okay, plus 180. I hit enter. on my screen. It doesn't matter where my start is. It doesn't matter where my step is. What I need to do is hit enter on ask. And then I go down and I hit enter on OK. And now I'm going to type in these numbers. Hit 0, enter. 1, enter. 2, enter. And let's record our values here. When I plugged in 0, I got 180. When I plugged in 1, I got 164. When I plugged in 2, I got 116. I still need to plug in the number 3, so I hit 3 and enter, and that's the number 36. That's going to give me my y values for this entire problem. So that's going to save me a lot of time. Okay? So what do I know my points are? My points are 0, 180, and 1, 164 for this problem. I need to do change in y over change in x. So that's going to be 164 minus 180 all over the x values, which is 1 minus 0. Go ahead and do that out, and let's see what you get. I'm getting negative 16. Of course, we want to label our answers, so this would be negative 16 feet per second. So let's think about what happened to that object from the initial start time to 1 second. Well, over that second, it should have decreased in height. The negative here means decreased in height by 16 feet. Over that 1 second period of time, it should have decreased in height by 16 feet. Okay, let's try the next one. Again, here we're finding the slope, the average velocity. That's going to be the change in, I keep on saying d, technically it's s, the change in position over the change in time. Well, let's think about our points. Here we have the points 1, 164, and we also have the points 2, 116. So let's do our change in height, change in position, so that would be 116 minus 164, all over the x values, or the t values in this case, which would be 2 minus 1. Put that into your calculator, let's see what you get. I'm ending up with negative 48. So what is that? Negative 48 feet per second. Well, since the time frame is 1 second, 1 to 2 seconds is 1 second, right? That means for the first second, it fell 16 feet. From second 1 to second 2, it fell an additional 48 feet. So what's happening? It's falling faster. Think about dropping an object off of a building. It starts off slow, and by the time it hits the ground, it's moving much, much faster. That's exactly what's going on here. Let's continue on. 2 to 3, think about those points. We decided earlier from the table it was 2, 116, and then it was 3, the height that 3 seconds was 36 feet, given to us by the original position equation. So if I want to find that slope, which is the change in the height over the change in time, that would be 36 minus 116 all over 3 minus 2. What are we getting when we put that in? Plug that into your calculator. I hope you get the same. I'm ending up with negative 80. So from second 2 to second 3, this thing was falling at an average rate of 80 feet per second. So let's think about the real world. What would be happening here? As the object falls further and further, it would be going faster and faster. If you know anything about physics, this is always going to happen due to gravity. As long as there's not too much air resistance, this would always happen. It would always increase until you actually reached terminal velocity. So again, that negative means that you're falling. The height is decreasing, or you're getting closer to the ground at that rate.